Buckle up, because the race to dominate the semiconductor industry has never been more intense. The growing demand for everything from artificial intelligence to cloud computing and advanced consumer devices has put silicon chips at the center of global competition. Four companies stand at the forefront: Nvidia, Samsung, Amazon, AWS, and Apple. Each is pursuing a unique strategy that reflects just how vast and intricate the semiconductor landscape has become. On one side, Nvidia began as a scrappy startup in the mid-1990s, focusing on graphics cards for PC gaming. The company nearly collapsed several times but secured its place in history with the GeForce 256 GPU in 1999. That technology introduced programmable shading and brought video games to life in ways never seen before. Over time, Nvidia became the go-to name for visual computing, powering everything from top-tier gaming to Hollywood special effects. But the defining moment came in 2006 with the launch of CUDA, which unleashed GPUs on tasks far beyond gaming. Deep learning researchers quickly realized that GPUs excel at handling the massive parallel workloads required by neural networks. Breakthroughs like AlexNet in 2012 put Nvidia's chips front and center in the budding field of AI, and now models like ChatGPT rely heavily on Nvidia's flagship A100 and H100 GPUs. The big drawback is that Nvidia depends almost entirely on TSMC in Taiwan for manufacturing, leaving it vulnerable to geopolitical frictions. US export controls also restrict the sale of its most advanced GPUs to China. Even so, Nvidia's expertise in parallel processing has placed it firmly at the heart of the generative AI boom. Meanwhile, Samsung has built an empire as a leading supplier of memory chips like DRAM and NAND, often controlling nearly half the global market. Memory prices, however, can swing wildly, and a recent slump caused Samsung to cut production. In response, the company doubled down on its foundry business, aiming to compete directly with TSMC in manufacturing high-end logic chips. Samsung is investing heavily in new facilities, including a $17 billion fab in Taylor, Texas, supported by the US CHIPS Act. The company also revealed plans to spend a whopping $228 billion on a mega cluster of fabs in South Korea, with the goal of hitting process nodes as small as 1.4 nanometers by 2027. This is an incredibly capital-intensive path, but Samsung's vertical integration, spanning everything from memory to consumer devices, gives it both scale and technical expertise. By offering an alternative to TSMC, Samsung hopes to attract companies that want to diversify their supply chains and avoid an over-reliance on Taiwan. In the data center realm, Amazon Web Services wields massive influence as the top cloud provider. Recognizing the need for greater performance at lower costs, AWS began designing custom silicon after acquiring Annapurna Labs in 2015. It introduced the Nitro system to handle functions like virtualization and security, freeing up server CPU resources. Next came Graviton, AWS's own ARM-based CPU for general-purpose tasks, and finally Inferentia and Trainium, chips purpose-built for AI workloads. While Nvidia still dominates large-scale training of models like ChatGPT, Amazon's custom AI chips give it a compelling alternative for certain workloads, especially inference, by offering better performance per dollar within AWS. As Microsoft, Azure, and Google Cloud ramp up their own AI services, AWS is countering with offerings like Bedrock, enabling clients to tap into third-party large language models without leaving the AWS ecosystem. Given the staggering amounts of data organizations already store on AWS, this strategy is poised to keep customers locked into Amazon's infrastructure for AI-driven projects, all backed by specialized silicon. Lastly, Apple shows how to use semiconductor innovation as a tool to unify hardware and software. Back in 2008, the company purchased PA Semi, laying the groundwork for its internal chip team under Johnny Srouji. The A4 chip, launched with the iPhone 4 in 2010, kicked off Apple's move to homegrown processors. By tailoring CPU, GPU, and neural engine designs to fit iOS and macOS, Apple unlocked major gains in performance and power efficiency that off-the-shelf chips simply couldn't match. This advantage expanded when Apple replaced Intel's processors in Macs with its own M-series chips. The M1 in 2020 stunned the industry by delivering remarkable speed and battery life, and subsequent iterations like the M2 and M3 have continued that tradition. Still, Apple relies on TSMC's foundries in Taiwan, exposing it to the same geopolitical risks faced by Nvidia. And while Apple designs nearly everything in-house, it remains dependent on Qualcomm modems for cellular connectivity, at least through 2026. Although some observers say Apple lags in generative AI, the company has quietly advanced on device machine learning, and many speculate an Apple GPT is on the horizon. Taken together, these four companies demonstrate how semiconductors have moved beyond a mere supporting role. They're now at the core of critical developments in AI, data centers, smartphones, and beyond. Governments around the world, led by the US, are pouring resources into local chip fabrication through legislation like the CHIPS Act, emphasizing the national security dimension of keeping advanced chip production close to home. At the same time, engineering breakthroughs continue to push feature sizes below 5 nanometers, demanding astronomical investments. Whether it's Nvidia's leadership in GPUs for AI, Samsung's ambition to rival TSMC in advanced manufacturing, Amazon's push to build its own chips for cloud supremacy, or Apple's quest to integrate silicon seamlessly with software, the stakes have never been higher. This is a race shaped by technological complexity, colossal capital requirements, and a dose of geopolitics, all converging in what has become one of the most pivotal industries of the 21st century. One thing is certain: the companies that best navigate these challenges and capitalize on emerging chip technologies stand to define the future of innovation for us all.